Hello and good day, pre-algebra. It's been a long time, but we're back learning stuff. PO46, creating a function table for a given equation. This is the first objective of Unit 8, and we're starting out with a few definitions, which are also going to be possible definitions on the quizzes that you'll begin having tomorrow. So make sure that you're getting these definitions down, and if you've got a question about it, something that makes sense, then do ask it, okay? So that you're not left with an incomplete definition and then wouldn't be able to match it up on a quiz. So think about XY tables or function tables that you made before. What's the input? The input of a function. Maybe you've heard this term in science before. Maybe you've heard it in math before. Anyone have an idea of an input? John?
Like the XY.
So we're talking about X's and Y's here. Okay, usually the input is the X variable, but because my marker isn't working, because we'll try red. Because
Just unplug it and plug it back in. Yeah. Just plug it in and plug it back in.
any thoughts? You unplug it, plug it back in, you say. We will try that. Unplug.
Oh, hopefully it did.
No, it's still recording. Oh, it is showing up on my screen here when I unplug it. So that's weird. Plug it back in and see what happens.
I guess you'll just have to record it and then, give us the video.
Take a video on your flip phone.
Yeah. There we go. I don't know what's going on. Thank you, though, for that. Yeah. Okay. So, yes, the input is usually going to be the X variable, but because we'll be using variables other than X and Y, we don't want to rely on that. But more so, the input is what is being tested, okay? The input is the value being tested. It's what can change in an equation. Well, what happens if I do this? What happens if I do this? Okay? It's the value that is being tested. And we'll put in a situation to make it sound formal. The value being tested in a situation. It's what you plug into an equation. So the output, which is usually the Y variable in an XY table, but we'll be using other letters than X and Y, so we can't rely on that. But the output is the result. The result of testing the input. Okay? The result of testing the input. You can think about this in science terms as the input is like the control variable, right? And the output would be the, what's the other one called? The result variable. That's not right, John? You can tell I failed science.
Equal variable?
I don't know. The control variable, which you're kind of testing, and then the output would be the result. Okay? And a function table is a table that relates the input to the output. A table that relates the input to the output. And I know you made these back in 6th grade, so if it's not seeming very familiar now, it will shortly. You probably call them function tables or XY tables, input-output tables. Shane? We'll try. We'll wait and see. We'll wait and see. You might be surprised. Okay? Questions so far? All right. So let's make some tables, shall we? Scroll on down your page a little bit. And we've got 5 equations here. And to make a function table, we're using X and Y. Basically, we've got X, okay? We've got what the equation is, what the rule is, and then we've got Y. And the beauty of these is that you get to pick what you plug in for X, right? You get to pick what we are testing. So, Colin, give me your favorite number.
21.
21. If x is 21, that means in the equation, Tony, we're taking 21 plus 3. And what's the output? What's the result? 24. Okay? 21 is what we put in, is what we tested. That's the input. Again, typically the x. We're talking about x and y here. And 24 is the output, the result. Okay? Evan, what would you like to test?
What?
Pick a number.
3.
Sure. If x is 3, nothing in the table changes except for that x variable. We're still adding 3, only now we're testing an x value of 3 rather than 21. And what's the output? 6. Okay?
Wow.
Jeffrey, where'd you find it?
I have no clue. It's probably in the refrigerator we lost it from.
Can you go grab it? You had it for about 24 hours.
I know.
Can you go find it?
I'm disappointed in myself.
Thank you. Annie, give me a number.
26.
Sure. If x is 26, add 3 to it, what do we get? The output of?
29.
29. Okay? So the beauty of this is you get to pick what you are testing. You're picking the x value. If you don't like big numbers, don't pick big ones. If you don't like negative ones, don't pick negative ones. If you don't like fractions, don't pick fractions, right? You get to test it. Let's look at the next one here. Y equals negative 2x. So we've got x, we've got negative 2x, and we've got y.
Did you find it? How did it?
Come on.
All right. What would you like to put in here? Abby?
-5.
Negative 5. If x is negative 5, we're taking negative 2 times negative 5. And what's our result? Positive 10. That's the output. Okay? What would you like to test? Tony? 45. Okay? Negative 2 times 45. What do we get? What's our output? Cade?
What?
What's our output? Negative 2 times 45. Negative 90. Okay? One more. Dayton. Pick a number.
10.
Lovely. If x is 10, negative 2 times 10, the output would be negative 20. Okay? Do the next one on your own. I've got to calibrate this, and also I'm going to erase what we have here. So finish jotting down any notes that you want, and then tackle the next one on your own. Okay? Y equals 5x minus 8. You get to pick whatever input you want, multiply that by 5, then subtract 8, and you've got your output. So I will calibrate quickly and then be right back with you. Okay.
Obviously not interesting.
Right, you will not all have the same answers. That is correct. Okay, so someone give me one that they did there for 5x minus 8. Yeah, sure. Sophie, 5. When x is 5, our equation becomes 5 times 5. Ooh, that's a big erase circle there. Because 5 times 5 minus 8, and what do we get? What's your output? Sorry?
7.
17, I think, right?
Yep.
25 minus 8? 17? Someone else. Something they put in there. Tony. 20. If x is 20, 5 times 20 minus 8 gives us
92.
92.
Yeah, I can do the math.
Okay, what's
Okay.
Well, he's got it.
Camille.
1.
1. 5 times 1 minus 8?
-3.
Negative 3. Right? So again, you get to choose what these inputs are. It's what you're testing, what you're putting into the equation. And then the output, the result, is the y value. Okay? The next one, we throw an exponent at you. X squared minus 10. What would you like to test? What did you plug in, John?
5.
5. If x is 5, we get 5 squared minus 10, which equals what, John?
Got this, John.
So 5 squared, 5 times 5. And take away 10. 15 is correct. Okay. 15 is correct. Shay, what'd you pick?
60.
60! My goodness.
16.
Oh, I was going to say, that's quite the... 16 squared minus 10, what'd you come up with as an output?
No, wait.
What?
Anyone know what 16 squared is off the top of their head? Tony?
224.
Nope. Close-ish.
Oh, wait, 32.
No, that's 16 times 2. 16 squared is 16 times itself. Haley? 256, and then minus 10 gives us 246. Okay? One more for this one. X squared minus 10. Who wants to share the day? Camille?
3.
3. 3 squared minus 10, what did you come up with? Negative 1 is correct. Okay? So part of this is, like, on a test, you know, some of you kind of like to be creative with your numbers, but make sure you get the right answer when all said and done, right? It might be an opportunity just to play it safe. You know, stick with numbers that you know. This last one here, we want to pick smart values. Give me an example of a smart x value to pick. And by smart, I mean it's going to be nice. It's a nice, easy calculation. Okay, nothing too fancy. Kylie,
3.
why would 3 be smart, do you think? It's a lower number. Do you know what 1/4 times 3 is, or 1/4 of 3?
3/4. 2/12.
It's 3/4, but I don't want to deal with a fraction if I don't have to. Okay, so 3 would be fine. I mean, you could use it, but let's maybe a little bit better, more easily work out a little value. Cade,
25.
why would 25 be a smart, easy value to work with?
Or 100.
Why would 100 be a smart, easy value to work with?
That's 1/4 of 125.
Yes. Okay. We can easily calculate 1/4 of 100. Right? What goes into 100 four times? 25. Okay, so 1/4 of 100 is 25 plus 7 equals 32. I remember, like, 3 would be fine, but then you got to deal with the fraction. Do it if you want to, okay? But it is easier not to. Okay? John, what's a smart value that you want to use?
1.
Well, 1 times 1/4, I still deal with that fraction. I want to steer away. I'm a chicken. I don't want to do that. Abby?
32.
32. Why 32?
Because 4 can go into it.
Because 4 goes into 32. What's 1/4 of 32? What goes into 32 4 times? 8. 8 plus 7 is 15. Nice and easy. I like it. Okay? What's another one? Haley? 16. 1/4 of 16 is what?
4.
4. 4 plus 7 gives us 11. I like it. Tony, you have your hand up? Do you have another one? No? John?
40.
40. I like 40. 4 goes into 40. 1/4 of 40 is 10. Plus 7 gives us 17. So, again, since you get to pick these, you know, I don't know, take the path of least resistance here. Okay? Take the safe route, as long as you get to choose. All right? So anyway, why do we care about this? When we see this in, like, an actual situation? It says, after a week of timing yourself, I think I have to scroll up to get all the questions here. Yep. After a week of timing yourself for your morning run, you discover that you can run 4 miles per hour. 4 miles per hour. Let H represent the number of hours you run, and D represent the distance that you run. So we're not using X and Y here. We're using H for hours and D for distance. What's the input here? What's the output? If we want to figure out how far we can run based on how long we run, what are we testing? Are we testing the distance to calculate the hours? Or are we testing the hours to calculate the distance? What's being tested? What's the result we're looking for? This is oftentimes the hardest part, just setting up what's the input and what's the output. I do have a hint for you, a little bit of a shortcut, but what do you think? Are we testing the hours to conclude the distance or testing the distance to include the hours? Aid?
Distance hours.
We're testing the hours to conclude the distance. Okay? So the input is going to be H for hours. The output is going to be D for distance. Now here's the hint that you can use not only on your homework but also for the test. Okay? If you look at letter D, it says create a function table that will show how far you will run in 3 hours, 8 hours, 12 hours, 20 hours. What am I asking you to test? The hours, right? And since the what we test is the input, if I'm asking you to test the hours, you know that's going to be the input. So if you're having trouble identifying these, take a look a little further down the page. What am I asking you to test? And that's going to be a hint. Right? Now, what equation can we write here? That's going to allow us to calculate how far we can run based on how long we run. The total distance equals what expression? And I underlined something important in the original question. Okay? Okay, but it says 4 miles per hour. Remember, this hour is important. That's our H variable. The 4 is important too. How do we put that together? John?
1 divided by 4.
Not 1 divided by 4. Camille?
Is it like 4 plus like D, like distance?
No. What does the word per mean? What operation does the word per mean? It means we're multiplying. So 4 miles per hour, if we kind of break that down a little bit, this is multiplication, right? Here's our 4. 4 miles per hour, 4 times h. The total distance that we'll run can be calculated by multiplying 4 times the number of hours we run. 4 miles per hour. If we run for 1 hour, 4 times 1, we'll have run 4 miles. If we run for 2 hours, 4 times 2, we'll have run for 8 miles. Okay? So that word per, you can also think of each or every, very important. And all 3 of those mean that we are multiplying. Okay? Letter D, create a function table that will show how far you will run in 3 hours, 8 hours, 12 hours, 20 hours. So here's our function table, right? H, the rule is 4h. The output is distance, D. And this time, instead of you being able to pick what you're testing, I'm telling you what to test, which is helpful because, again, that kind of helps you identify what the input is here. Okay? So how far will you run in 3 hours? How do we calculate that? What do we do? Tony? 4 times 3. Or 3 times 4. And how far is that? What's the output? 12. In 3 hours, you will run 12 miles. What if you run for 8 hours? What is that? How does that change things? Camille? Right. 4 times 8. 32. Right? We're testing this. That's why it's the input here. What if we run for 12 hours? What's that going to result in, Wyatt?
12 times 3.
4 times 12, or 12 times 4, which gives us 48. What if we run for 20 hours? 80, which you get from taking 4 times 20. 80. So the whole purpose of a function table or an input-output table is to allow us to be able to test stuff. What happens if this? What happens if that? Okay. Finally, letter E. How long will you need to run to go 62 miles? How does this change things? What variable am I giving you now? Abby.
You have to figure out the hours from the distance.
Right. This case, I'm giving you the distance. You need to calculate the hours. Our equation stays the same here. D equals 4 times H. But instead of giving you a value for H, I'm now giving you the value of the distance. 62 equals 4 times H. How many hours will it take us to run 62 miles? What would your step be to solve this? What would your step be to solve this? Okay. Right, a one-step equation. We're multiplying 4 and H together. So divide both sides by 4. And that ends up being 15 and a half. 15.5 hours. It's a long time to run. The next question says, if you burn 250 calories per hour, how many calories will you burn? Someone walk us through how to answer that. If you burn 250 calories per hour, how many calories would you burn, Haley? How would you go with that?
250 times 15.
Right. 250 calories per hour, that word per again, right? If we're running for 15 and a half hours, 250 times 15.5, what'd you say? 3,000 what? 3,875 calories. Right? Questions on this? Was I correct that you've seen this before? Yeah? Yeah? Okay.
I don't want to check my own math here.
Yeah. Let's look at the second situation here. We'll get this started, and probably this is going to be left for homework. Which one do I want to do here? I want to do. We have a lot of them to do. My goodness.
Senorita, can you please dial 103? Senorita, dial 103.
You pick up a summer job that pays a base salary of $500 and an additional $9 per hour work. So it's like you have a $500 signing bonus here, and then you earn $9 per hour that you work. Yes, sir.
You actually start working when you're 14.
Yes. The spring break of my 8th grade year, here I thought it was going to be a nice, relaxing time. Could spend all my days playing Mario, whatever I wanted. Monday morning, 6 a.m., my dad shakes me awake. Hey, I got you a job. Let's go. And so I was working over spring break.
That's scary.
Where?
Where did you work?
It was a company called All City Assembly, which basically assembled like if a large company was having a conference in the Twin Cities and they had like packets to hand out to people, we assembled the packets. We put each page in, and it was 8 hours of standing and doing the same thing over and over. It's like an assembly line, but you know what? Build character. What it did. Yeah. I did get paid. Yeah. Minimum wage that time, which was like $7. Well, no, I got $7.50 an hour, which for a 14-year-old kid, pretty good. I guess. Didn't have any bills. Jeffrey.
Where could you actually work right now if you're
15.
That was routine.
I guess I've not checked the job market for 14-year-olds recently, so I guess.
Legally, it's 15.
Anyway, back on here. So you have like a $500 base salary, $500 signing bonus, and then $9 per hour worked. Okay, so let's just think of the situation here. If you want more money, what should you do? Work more hours, right? And so if you think about if you H represent the number of hours worked and M represent the money that you earn, what's going to be the input here? And remember my hints where to look if you're not quite sure. What's being tested and what's the result, right? What's being tested? What's the result? Sophie, is the input for hours worked, right? And then the result of that, based on the number of hours you work, what do you get out of it? You get paid, right? Money. Okay? You work more hours, you make more money. You work less hours, you make less money. Not a extremely difficult concept there. What equation is going to relate the input to the output? So the amount of money that you make, how can you calculate that? And again, look at here's kind of the key sentence here. Anyone new want to chime in today that hasn't had a chance yet? That is just itching to get involved? Oh, Tony, what do you think? Okay, Sophie? 9 times H is part of it, right? That's the amount that you'll make based on the number of hours. But what about that 500? How does that come into play here? Camille? Yeah. Does the 500 change based on how many hours you work? No. Right? That's your base salary. That's your signing bonus. However you want to think about it. It's a one-time thing. Okay? One-time thing. But the $9 per hour, 9 times H. For every hour you work, you'll make $9 more. So for our function table, we've got the hours. We've got 9H plus 500. And we have the M. We're going to fill in the inputs for this. The rest will be homework for you. The rest of D and then E. I think we can play the number game tomorrow. It's been a while. Let's start try 3 off with a bang. But what inputs are we using here? It says create a function table that will show you how much you'll earn after working an hour. What number am I putting in for my H for my first row?
8. Or no,
1. 1 hour work. Okay. How about if you work a day, which is 8 hours, a work day, typical. What number am I putting in for the input there? 8, right? Not 1 for 1 day. Our unit is in hours, so it needs to be in hours. Now it might get a little bit tricky. What am I putting in for a week,
5.
which is 5 days? I can't put 5 because 5 is in days, whereas our unit is in hours. So if we know that a day is 8 hours and it's 5 days, what am I plugging in there? 40, right? 40. Which is 5 days times 8 hours. That's where this 40 comes from here. Okay? 5 times 8. So it's 5 days at 8 hours each day. How about a month? Which is 4 weeks. What am I plugging in there? What am I plugging in there? Abby?
160.
How'd you get 160?
40 times 4.
And why 40 times 4?
Because 5 days are 4 weeks.
We already know that a week is 40 hours. We got that from the last one. So if we want to work for a month, which is 4 weeks, right? 4 weeks times 40 hours per week gives us 160 hours. We have to make sure that what we're plugging in here is the same units as what we stated that it is, right? Our unit is in hours, so we have to write a month in hours. We know a month is 4 weeks, a week is 40 hours, 40 times 4, 160. Jeffrey, Quinton, Warning Street Review 5, please. Camille.
What if it's February?
It's not. Moving on. I don't know. Okay. This is a situation. Let's just go with it. Right? Okay. You can finish the rest of letter D here. Plug those inputs in. How much money are you making? What's the output? And then letter E, it says about how many hours do you need to work to earn enough to be able to deposit $750 into your savings account. Right? Sometimes you have an end goal in mind. I need to save this much money for this, for a summer camp, for a phone, for deposit, for whatever, right? So in this case, again, your equation doesn't change, but now you're plugging in the amount of money you want to earn to determine how many hours you need to work. Okay, so kind of switched up like we did in the previous one. John.
So like for as another example, something you're trying to get a VR headset.
Sure. Yeah. I can't do VR. It makes me nauseous.
I can.
Yeah,
like
I
VR. It's
can't.
fun.
Ethan. Yep.
So we just have to do E for homework.
D and E. Finish out this question, which is letters D and E for homework. Other questions, comments, concerns, complaints, comments, congratulations, or criticisms?
Congratulations!
Thank you, John. Abby.
We don't have to finish the whole thing.
No, not the whole page, just this one. We'll pick it up tomorrow. Sorry, this is a pretty wordy lesson. There's a lot to talk about, but it's a long recording. My apologies for that, but sometimes that's how it works. All right.
Don't forget to like and subscribe.
Thanks, John.